number more than 100. Okay. Now basically what we say over here is that there were many elements which were discovered, and approximately there are 112 elements which had been discovered, and slowly now as of now we have 118 elements which are discovered. Okay. Now elements which come after uranium, all elements coming after uranium, they do not exist naturally, and hence these elements, they are known as trans uranium elements. All elements coming after uranium, they are known as trans uranium elements. The atomic number of of uranium, that is 92. Okay. Then the elements with Z is equal to 104 to 118. All those elements with atomic number 104 to 118, they are known as transactinides. They are known as transactinides, or they are also known as super heavy elements. They are also known as super heavy elements. All these elements, they are man-made. They are synthetic. Okay. Now synthetically, when these elements they are prepared, they require certain special equipments which are known as nuclear accelerators. Okay. As of now, there are only two centers in the world which are making man-made elements. One which is in California, in USA, and the other one is in Moscow in Russia. These are the only two centers which are forming or which are discovering or which are making man-made elements by nuclear accelerators. The elements with, for example, we'll be talking of element with the zinc, atomic number 104. It was named as Rutherfordium by USA. That is, when they were discovered, it was discovered in California, and same was named as Kurchatobium in Russia. Now, to avoid such kind of confusions which were taking place, the IUPAC nomenclature gave certain rules and regulations to name elements above atomic number 100. Okay. Now, to avoid, like if we have the same name given for the same element, two different names are given for the same element, then it is going to be utter confusion. Therefore, certain rules and regulations were followed by the IUPAC to name such elements. Right? What were these? The names were derived using numerical prefixes. The numericals were, or the numerics were given certain prefixes which depended upon the digit which was present in the figure. Okay. Like for example, if the digit that was 0, the name given was nil. If the digit was 1, the name given was un. If the digit was 2, the name given was bi. If the digit was 3, the name given was tri. And if the digit was 4, the name given was quad, pent, hex, hept, non, hept, oct, and n. For 9 it was given, the name given was n. Right? Then all of these, it was followed by a suffix It was followed by a suffix which was em. Right? Like for example, if we have 101 as the atomic number, okay, for 1 the name, the prefix given is going to be un, then nil, then un and ear. Un, nil, un and followed by a suffix which is ear, right? So the element with atomic number 101, that is known as un, nil, un, ear. Clear? Then if it is 102, then it will be un, nil, beer. Okay. Now over here, double I is supposed to come, by ka I and ear ka I. So we have cut shorted to BIUM. Okay. Then if we have 112, then 112 will be un, beer. And if it is 114, then it is going to be quadrium. Right? And the last element with atomic number 118, that would be known as octium. Right? So this is how the nomenclature with these words were given. Now in certain cases, as I just told you that the names were shortened. For example, if we are getting BIIUM, so instead of this BIUM was written. So the name it was shortened. One I that was cancelled from here. Okay? Clear? Now the symbol for element, that is, obviously we have to write down the symbols also over here. The symbol of elements that was made from the first letter. First letter. For example, if we have, we are taking 101, un, nil, un, ear. The name which we have written over here. The symbol of this will be un, say you will take U, N say you will take N, and again U say you will take U. U and U. Okay. Similarly, when we are over here, from U, from un we will take U, from nil we will take N, and from beer we will take B. So these are how you are going to represent the symbols. Clear? Okay. Then after that, officially when we are talking of, officially only those elements with atomic number 112 have been approved. Rest above 112, that is 113 to 118, they have not been officially approved till now. Clear? So this is what the IUPAC system is. Then let's go on to the relationship between the electronic configuration and the periodic table. Next is relationship between electronic configuration and periodic table. Now when we are talking of the electronic configuration, we had already studied this, that the Aufbau principle. What does the Aufbau principle say? That Aufbau principle says that the shells, they are filled in order of increasing energies, right? Now according to the Aufbau principle, if we are talking of, it gives us a theoretical foundation. Aufbau principle gives us the theoretical foundation of periodic table, right? It is going to give us the theoretical foundation of the periodic table. Now according to this, the periodic table, it is basically what? It is a consequence, or it is made due to periodicity in properties. This we had done, that a periodic table that was arranged in order of increasing atomic numbers, and the same electronic configuration that was recurring after special or after regular intervals, which thereby gave periodicity in properties. Depending upon this, the elements in a group, we have already done the Mendeleev's periodic table, in which we classify the elements into groups and in periods, right? So we say that the elements present in a group, an element which is present in a group, it has similar chemical properties. Why do they have similar chemical properties? Due to similar electronic configuration in the outermost shell. Due to similar electronic configuration in the outermost shell, the example of which we had taken in the last class, the alkali metals starting from lithium and ending up to cesium. They all have the same electronic configuration in the last shell, and therefore they have similar chemical properties. Now, sequence in which the various energy levels are determined, right? In which the various sequence in which the various energy levels are filled, that is going to determine the number of elements which are present in each period. Like for example, if we are talking of period 1, in period 1, first period, we are only filling 1s, right? Therefore, the first period is going to have only 2 elements, because s can accommodate only 2 electrons, 1s1 and 1s2. So the first period has only 2 elements. When we are talking of the second period, in second period we are filling up 2s, right? And we are filling up 2p. So how many number of elements according to this? 2 in this and 6 in this. So we are going to have 8 elements, right? Then when we go to the third period, we will fill 3s and we are going to fill 3p. So the third period also consists of 8 elements. 2 and 6, that is 8. When we go to the fourth period, we are going to fill up 4s, we will fill up 3d, and we are going to fill up 4p. So how many elements now? 2 in this, 10 in this, 12, and 6 in this, 18. So number of elements, they are going to be 18. ठीक है? फिर उसके बाद we have the fifth period. Fifth period we will fill up 5s, we will fill up 4d, and we will fill up 5p. Right? So again, how many elements are going to be present? 18. When we go to the sixth period, in the sixth period we fill up 6s. Then according to Aufbau principle, we are going to fill up 4f, 5d, and 6p. So how many elements now? 2, 14 and 2 is 16, 16 and 10 is 26, 26 and 6 is 32. So the number of elements which we are going to fill up over here, they are going to be 32. Okay, and the same goes for seventh period. In the seventh period we will fill up 7s, we will fill up 5f, then over here we will fill up 6d and 7p. So again the number of elements which are going to be present over here, they are going to be 32. Right? Now depending upon the electronic configuration, we classify the elements into the following. So depending upon the electronic configuration, we classify the elements into the following. The first one, they are known as inert gases. In the inert gases, we are going to fill up only S and P subshells. The outermost shell, that is going to be either S or P. Like for example, in helium we are filling up S, whereas the rest of the noble gases we are filling up S and P, the outermost shell. Inner we are filling up D and F both, but outermost we are only filling S and P. So the noble gases which we have, they are helium, neon, argon, krypton, xenon and radon, from which radon, that is radioactive in nature. Okay, now the noble gases, they are so called, or inert gases, they are so called because they do not easily react at room temperature. Okay, so that is the reason they are known as inert gases, or they are also known as noble gases. The second type of elements which we have, they are the representative elements. They are the representative elements, or they are also called normal elements. Right? Now in representative elements or normal elements, the outermost shell is incomplete. The outermost shell, that is going to be incomplete. Okay, so if you are filling up for alkali metals, it is going to be NS2, NS1, NS2 and then NP, that is not filled. Right? Then when we are going to halogens, where it is NS2, NP5. So P is not completely filled. Therefore we say that the outermost shell in this case, it is going to be incomplete. Now this representative elements, they are the most versatile kind of group which is present in the periodic table, and they consist of all categories of metals, non-metals and metalloids. Right? So they consist of all metals, non-metals and metalloids, and they are quite active in nature. They are very, very reactive. Okay. Now in this type, when we are talking of, we say that all kind of valencies are represented. All the three valencies are they are represented. Right? What are the three valencies? The first one, which is +1. Okay. Then we have +2. Then we have 0. Okay. Then we have negative. Three valencies means positive valency will be represented by this. 0 will be represented as by the noble gases, because noble gases also comes in the representative elements, and then negative valencies as in the case of the oxygen and halogen family. They both represent the negative valencies, right? Then the third type of elements which we have, they are known as transition elements. In case of transition elements, the outermost shell, and penultimate. Penultimate is the inner shell to the most outermost shell, right? The penultimate shell is incomplete, right? Like for example, if we're talking of transition elements, then the general electronic configuration of this element, that is going to be n minus 1, 1 to 9, ns, 1 or 2, okay, and np 6, right? So the d subshell over here and the n subshell over here, this is the outermost shell and this is the penultimate shell, right? In both the cases they are incomplete. These are the transition elements. Okay, now when we're talking of transition elements, they consist of periods 4th, 5th, 6th and 7th. They consist of periods 4th, 5th, 6th and 7th. These are known as transition elements. Why? Because they show a gradual transition horizontally also and vertically also. So they have a relationship which they show horizontally and vertically both. That is the reason why they are known as transition elements. Now in transition elements there are going to be 4 series which are present. First series, in first series we fill up 3D. So this is also known as 3D series. Okay, the 3D series, it is going to start with scandium with atomic number 21 and it ends up in zinc, atomic number which is 30. Scandium to zinc. So this is the first transition series. We will do it in detail once you go to the transition elements. But right now you should know this, that the first transition series in which we are going to fill 3D elements. Okay, so there should be how many elements present? There should be 10 elements, but the last element zinc, that is not included in this element because it does not correlate with the definition of the D block elements. So there are 9 elements present in this series starting from 21 to 29, which is copper. Okay, but because zinc is placed at the end of this series, therefore it is also taken in the transition series. Then the second series present is going to start from yttrium. In the second series we are going to fill up 14. It starts from yttrium with atomic number 39 and ends up in Ag with atomic number of 47, silver. ठीक है? फिर उसके बाद we come to the next one, the third transition series, which is in which we are going to fill up 5D. ठीक है? और इसमें it starts from lanthanum, right? And lanthanum से लेके we are first filling up the F block series or the heavy transition series, inner transition series, which we call from lanthanum to lutetium. We fill up that, and then from hafnium. Hafnium is the D block. Okay. Then from hafnium we are filling up gold, which is 79. So lanthanum, the atomic number is 57. First we fill up the 14 elements from lanthanum to lutetium, and then from hafnium to gold we are filling up the 3D series, right? And then the last 4D series, that is, sorry, there's a mistake over here. यहाँ पे Ag तक नहीं आएगा, जिंक कैडमियम आएगा, cadmium with 48. Cadmium is not placed in this series. Similarly, यहाँ also the last member that is going to be mercury. To mercury. Okay. Then the fourth transition series, in which we fill up 6D, which starts from actinium and is not yet complete. Actinium, so we are filling from actinium to lawrencium, we are going to fill the F block, and in between we are going to fill it from rutherfordium. Okay, is it clear? So this is the transition series. Then the last one, that is the inner transition elements. Inner transition elements. The inner transition elements, they have the general electronic configuration as N-2, F, 1, 2, 14, right? N-1, D, zero or 1, and NS2. NS2. So this is also known as F block elements. There are only two series which are present over here. The first one, which is known as Lanthanides. The first one, which is known as Lanthanides. It consists of 14 elements starting from cerium with atomic number 58 to lutetium with atomic number 71. Okay, so these are the lanthanides, and the second series, it is known as actinides. Actinides. Now in case of lanthanides, we are going to fill up 4F, and in case of lanthanides में हम कौन सा fill up करेंगे? We are going to fill up 4F, yes, 4F, and in actinides we are going to fill up 5F. ठीक है? So actinides, it starts from thorium to lawrencium. Lawrencium, which has an atomic number of 103. Right? So in lanthanides we are filling up 4F gradually, and in actinides we are going to fill up 5F. Now mostly the members of the actinide series, they are radioactive in nature. Mostly the members of the actinide series, they are radioactive in nature, and most of them are not found in nature. They are man-made. Most of the elements, they are not found in nature. They are man-made. Now let's draw the periodic table first, and then we go on to the differentiating electronic configuration. The periodic table consists of 7 periods and 18 groups. Okay, so 7 periods means we have the first period, the second, third, fourth, fifth, sixth, and seventh. Now each of the period represents the principal quantum number. So over here, n is equal to 1. The first shell is filled up. The second, third, fourth, 5, and n is equal to 7. Right? So the first period, it consists of only 2 groups. As I just said, there are 18 groups over here. So we have first, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, be 18 groups. In the first group, in the first period, only 2 elements are present. The one is hydrogen and the other one is helium. Okay, फिर उसके बाद in the second period, when we just let's go group wise because it's easier to learn. So we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Right? So this is the first period. Then we go on to the second period. In the second period we have beryllium, magnesium, calcium, strontium, barium and radium. ठीक है? Then the second and the third, the D elements are not filled up. So we go on to 3rd to 12th is the D block. So we go to where? We go to 13. So we have boron, okay, so emerging lines will get, they're emerging with each other. Okay, so let's go on to group 13 over here. We have boron, which is the next one, aluminium, gallium, indium and thallium. Okay, then group 14 consists of carbon, silicon, germanium, tin and lead, right? Then group 15 consists of nitrogen, phosphorus, arsenic, antimony, bismuth. Then 16 consists of oxygen, sulfur, selenium, tellurium and polonium, right? Then 17 consists of fluorine, chlorine, bromine, iodine and acetylene. And then last, the noble gases. The noble gases, they were not discovered during the time of man Eve. They were discovered later, right? So next is helium, neon, argon, krypton, xenon and radon. Now below this is the main portion of the periodic table. Below the periodic table, the lanthanoids and actinoids, they have been separately put into different groups, which come below this. Clear? Now when we are talking of the first, second and third period, we just wrote down that the first period only consists of 2 elements. One is hydrogen and the other one is helium, right? Then the second one consists of how many? 8. The third consists of 8. The fourth is going to consist of 18. So over here, the 3rd to 12th is also going to be filled up. So which is the third one? We have scandium, starting from scandium, titanium, vanadium, chromium, right? फिर chromium के बाद next कौन सा आता है? Manganese, iron, cobalt, nickel, copper and zinc, right? So these are the elements of the which series? 3D series, the first transition series. The next transition series, that is starting from yttrium. After yttrium is zirconium, niobium, and after niobium it is going to be molybdenum, technetium, okay? And after technetium it is which one is it? After technetium it is ruthenium. Ruthenium, then rhodium, rhodium के बाद palladium, silver and cadmium. ठीक है? Then we come to the 6th. N is equal to 6. It starts from lanthanum to lutetium, as I have told you. So we are not going to do this over here. We will do it once we do the D block. Right? Now when we are talking of, same is here also. 7th period also we will do later. Right? Now when we are talking of the entire periodic table, the entire periodic table that is further classified according to the differentiating electron classification. What do we understand by differentiating electron classification? The outermost electron which is present in the outermost shell, which gives every element or every group its chemical properties, that is known as differentiating electron. Like for example, if we are going to this group, we say that the general electronic configuration of this group is Ns1. So this electron which is entering the last shell, that is known as the differentiating electron. Depending upon the differentiating electron, the entire periodic table is further classified into 4 blocks, right? Or 4 different blocks depending upon where the differentiating electron is entering. To the extreme left, we have the S block. The S block consists of group 1 and group 2, right? Apart from hydrogen. The general electronic configuration of group 1, as written over here, that is Ns1, and that of group 2 is Ns2. So these elements, because the outermost electron is entering in the S shell, S subshell, these are known as S block elements. So the S block elements is going to consist of group 1 and group 2. The group 1, they are known as alkali metals, and group 2, they are known as alkaline earth metals. Okay? Then we go on to from group 13 to group 18. In group 13 to group 18, we are progressively filling the P subshell. Therefore, these elements, they are known as P blocks with general electronic configuration Ns2 Np1 for group 13, Ns2 Np2, Ns2 Np3, Ns2 Np4, Ns2 Np5 and Ns2 Np6. Except for helium in the 18th group, which has electronic configuration only Ns2. Okay, so these elements, they are known as P block elements. The P block is one of the most versatile blocks in the entire periodic table because it consists of all metals, non-metals and metalloids. Right? So group P has all metals, non-metals and metalloids. Whereas when we are talking of group 1 and 2, it only consists of metals. We will come on to the characteristics of different blocks in the next section. Then next we are classifying from group 3 to group 12. Okay, now group 3 to group 12, this is known as what? They are known as the D block elements or the transition series, as the outermost electron is entering into the D block. As I just told you, they are known as transition elements. Why? Because they have relationships horizontally also and vertically also. And another reason is that they show a gradual transition or change in properties when we are traveling from S to P. Okay? And then last, below the periodic table is the F block, right? So F block, which are known as the inner transition series, which have only 2 series. One is the 4F series or known as the Lanthanoid series, and the other one is the 5F series, which is known as the Actinoid series. Clear? So this is the periodic table. Now let's discuss the general characteristics of all the blocks separately. We have already said that the S and P, they are collectively known as representative elements. Okay, so let's go on to the characteristics of S block elements. Characteristics of S block, right? Now when we are talking of S block, as I just told you, the S block consists of only 2 groups. One which is known as the alkali metals with general electronic configuration of Ns1 and the other one which is known as the alkaline earth metals with general electronic configuration of Ns2. The metals which are present in group 1, they start from lithium, sodium, potassium, rubidium, cesium and francium. Over here francium that is going to be radioactive in nature. ठीक है, फिर उसके बाद Ns2 आ गया. Ns2 में भी start with beryllium, magnesium, calcium, strontium, barium and radium. Over here radium is radioactive in nature. Generally you would see that we will not be studying the general trends of the radioactive elements. Why? Because they are short-lived. They keep disintegrating, as a result of which it is difficult to connect to their properties. Okay, so when we are talking of the alkali metals and alkaline metals, both these metals, they are soft metals with low melting and boiling points, but high conductivity. They are good conductors of heat and electricity. Right? So this is how we are going to differentiate them from the rest of the metals, that they are soft metals and they have low melting and boiling points. Right? Then second, they have lowest ionization energies. Because of their low ionization energies, it is easy to extract the electrons or remove the electrons, as a result of which we say that they have or they are electropositive in nature. They are electropositive in nature. ठीक है? Then the third characteristic is that they are very reactive and generally form ions quickly, and they form two kinds of ions. One which is monovalent, as in the case of alkali metals like Na positive, right? And the second type of ions, they are divalent, as the alkaline earth metals they form, as in the case of Ca2 positive or Mg2 positive. ठीक है? Then fourth, they generally form ionic compounds. Because they readily form ions, therefore they have the tendency to form ionic compounds, except for lithium and beryllium. Because of their high ionization energies, they are going to form covalent compounds. ठीक है? फिर उसके बाद they all are strong reducing agents. Lithium being the most strongest reducing agent amongst all. Now, why do they behave as reducing agents? There are two reasons. Because of number one, low ionization energies, they can easily get away with their electron, and second, because of high values of negative electrode potentials. ठीक है? Because they have high negative value of electrode potentials, therefore they are generally strong reducing agents. Now, while preparing these, because of the negative electrode potential, we study one more property of alkali metals, That is that when we are preparing the alkali metals, we cannot do so by electrolyzing the aqueous solutions. Okay, because whenever we are electrolyzing the aqueous solutions, the main product over here, that is going to be hydrogen at the cathode rather than the alkali metal. Right? So that is one drawback over here, and they have great affinity for oxygen and non-metals because they are highly electropositive in nature. Therefore, they have great affinity for oxygen and non-metals, and their oxides are basic in nature. Their oxides, they are going to be basic in nature. Okay? So today we are going to do only till here. Tomorrow we shall discuss PDF, characteristics, and then go on to the general properties and their trends in the periodic table.